We've been doing our sign analysis since the first semester, where it's like we know about a derivative, we know whether something's increasing or decreasing. But we haven't talked about how much. How much are we going up? How much are we going down? Today is really the beginning of what the second semester is really about in calculus. Today and tomorrow, the next class, we start talking about how much, and we add another layer to our sign analysis. To set the stage, let's start with this question. If I told you I had to get away from you, and I drove on I-35 at a velocity of 70 miles per hour from t equals 1 to t equals 3 hours, how far did I travel? Are you neighbors? No.
70 miles.
No. Look at your notes, dude.
Oh, yeah.
Okay. You have probably remembered from physics. Lock it. Please be locked in for today's lesson. That displacement is a velocity times a time. It makes sense. If I have 70 miles per hour over the course of 2 hours, what I get is miles. The hours cancel, and I get 140 miles. Now, what is that visualization of that 140 miles? Well, if I look at the graph of velocity, where does 140 show up? It would be this 70 times these 2 hours, or this area. Would you agree that this area, which is a height of 70 and a width of 2, this would be 140? Cool. All right. This is something easily calculated. We didn't need a calculator to do it because it's a constant velocity over the course of 2 hours. Got it? Great. Well, here's another situation that is not easily done. I'm in a rocket-propelled car because I need to get away from you faster. We're only talking about feet per second because this thing accelerates very quickly from the first second to the 5th second. Okay? We have a major problem with the question, how far did I travel? The major problem is that my velocity is not consistent. It's not always going to be 70 miles per hour. My velocity is changing. Cool? But we kind of know from the previous one that the area underneath this velocity curve from 1 to 5 would be a visualization of the amount traveled. Now, it would be nice if I could maybe take my velocity at a split second, multiply it by that small time in which I'm at that velocity, and just start adding up, or really accumulating all of my velocities at those very, very small split seconds to find this area. It'd be nice. Now, can't do that by hand, obviously, because it's a lot of calculations what we'd have that we'd have to do. But it's I want to find the area, and it seems I want to accumulate all of my velocities by the very, very small time periods in which I'm at that velocity. Or I really want to just accumulate my velocity over my interval. Well, your calculator can actually do that. Okay, everybody, have your calculators out? Great. Let's see how your calculator can accumulate a bunch of small velocities over a time interval. Open up your calculator. Let's go into y equals. Everybody in y equals, great. You've never done this before, ever, in your mathematical lives, so everybody's a calculator baby right now. Let's go ahead and graph 3t squared, please. Everybody do this. 3t squared. Oh, wait. I graphed 3x squared. It's okay. I'm just replacing x with t. This is me graphing 3t squared. Cool. And I'm going to graph it over the interval 1 to 5, but just so I can see things a little bit better, I'm going to go from 0 to 6. So everybody, let's adjust your window to 0 to 6. And do you guys remember how to make the graph like you see all of the graphs that you want to see over your interval? What is it? Zoom what? Zoom 0 or zoom fit. Good. We will be zooming fit a lot. Zoom fit 0 to 6, 3x squared. This is the graph of velocity that I see on my paper. Okay. I want to find the accumulate button. I want to find the sum all of these velocities button. Okay. Let's go into second calculate. And I see value. Okay, that's not it. I see 0. Okay, I know what that is. Min, max, intersect. I see a derivative, and then I see an S. Now I know this is probably meaning antiderivative, but like I kind of look at this, and it looks like it's a big S, like it's a sum. This is actually your calculator's button for accumulate. It should just say like accumulate. It doesn't. It has an integral. We'll talk about why they use this symbol for accumulate next class, okay? But for right now, you're just gonna be like, oh, that symbol to my calculator means add up, accumulate all of my velocities or find the area. Let's go to 7, let's press enter. We need to give it an interval. I got 1 and 5, so let's type in 1, press enter to set my lower limit. Let's press 5, then enter to set your upper limit, and let's see something beautiful on your calculator that you've never seen your calculator do before. Yo, 124. 124 feet. That's that area. That is your calculator accumulating your velocities over this interval, like velocities times very, very small times. It accumulates the velocity over the interval. It summed, and it got this number, 124. 124 feet is my answer. It took my velocity, which was feet per second, and it multiplied by the seconds in which we are traveling. The seconds canceled, we get feet, okay? Guys, this brings up something very, very important. Accumulating derivatives. If you accumulate a derivative, what do you get? Well, if you accumulate velocity, which is the same as a position derivative, you are accumulating feet per second or miles per hour over an interval, you get feet. You get a change in position. If you accumulate a derivative, you get a change in whatever you started with. We'll call a total. Now here's the notation we will be using for accumulation. Doesn't make sense right now. It will next class. We're going to use a very tall, skinny s. Yes, it is an integral. But to my calculator, that integral doesn't mean antiderivative. To my calculator, that integral means sum up, add up, accumulate. You will accumulate your velocity, say your 3t squared, over your time interval. To denote your time interval, you will place numbers in order in your integral, where the bottom number is your start and your top number is where you're going to end. You will be able to do this very thing in your home screen. Go into your home screen, get out of your graphing, go second quit. Quit is above mode, second quit goes to your home screen. Everybody in your home screen, go to Math, FNINT. Now again, why doesn't it say ACCUM? It doesn't for a reason we're going to learn next class. But for right now, you go to FNINT, an integral pops up. To you, an integral means antiderivative. To your calculator, the integral means accumulate. You will say, hey, I want to accumulate over the time interval 1 to 5, my velocities 3x squared. You will have to put dx because it's talking about your velocities times time. Velocities meters per second times the seconds gives you meters. This is the other way that you will be able to get your answer of amount traveled. If this is feet per second accumulated over these seconds, that's how you're going to get feet. Okay? We will be able to accumulate from a start to an end any derivative. And when you accumulate a derivative, you are going to get a change in whatever you started with. Or, more importantly and more easy to understand, you have a sign analysis, right? Let's say the signs of my derivative were positive. You know that your position is increasing because its derivative is positive. We will add a new layer. The accumulation of your derivative, which will give you a number, will tell you how much we increase or decrease. The accumulation of a derivative tells us how much we go up or down. That's the idea behind like changing. Okay. Now, this first situation and the first two situations I'm going to show you, we actually don't need a calculator, but I'm showing you how like you could use your calculator to get the answers that we kind of know. What happens if your velocity changes sign? What if your velocity goes from positive to negative? Well, like, let's start with a sign analysis of this velocity. Okay, here's the velocity. Velocity is the derivative position. V equals x prime. Cool? Focus. I got positive velocity until 4. I got negative velocity until 10. I know my position increases, then decreases. In this situation, I'm very easily able to do this without a calculator, but I'll show you how you could get the same answer with a calculator. We are going to add another layer. the accumulation of my derivative, the accumulation of my velocity from 0 to 4. Well, this area here is 12. That's telling me how much my position increases. In your calculator, type in 0 to 4 in an integral of just the number 3. Have your calculator accumulate 3 from 0 to 4. Go math 9. Type in 0 to 4. Put 3. dx. Like, that's just accumulating 3 over the interval of 4. Yeah, you get 12. It's obvious. Now, we wouldn't use your calculator for that instance, but if your velocity was changing, that's where your calculator is going to come into play. Now, when your velocity is negative, okay, this is new. Great. We are going to accumulate a velocity of -5 over the interval of 6. I'm going to actually say that this area is -30. Because it should make sense to me getting a negative value. If accumulating a rate of change gives us an overall change, accumulating this -5 should give me this -30, which will tell me how much my position decreased or how far I traveled left. Now, here comes our key idea about displacement. What would be the accumulation of my derivative from 0 to 10? What would that equal? Tell your neighbors, and tell your neighbors, what does that number that you got mean? If you accumulate your derivative from 0 to 10, what do you get, and what does it mean?
You end up
Oh, yeah.
-5 from 4 to 10 is -30. That's all you should do. So since we have different velocities, you can't go 0 to 10. We're just going to have to look at what we got from 0 to 4 and 4 to 10. Add them all up. What do you get? -18. That's the answer. The answer is -18. Okay? Sorry for confusing you with the open-ended question. I'll explain a little bit more. Why is it -18? Well, it's like I accumulated all of my derivatives from 0 to 4 and all of my derivatives from 4 to 10. I just added those things together. It got me -18. But what is the meaning behind this? I end up 18 units to the left of where I started. Why does that make sense? Because I'm going to go to the right 12. I'm going to go to the left 30. If you go to the right 12, then the left 30, you will end up 18 to the left of where you started. This is how my position changed over the interval. Lee.
Whenever if you put that into your calculator, what would you put into it?
Well, because x prime changes, I'd have to split it up. I'd have to go 0 to 4 of 3. I'd have to go to 4 to 10 of -5 and just add those two numbers up. I can't put in just a specific derivative because it's like a piecewise kind of deal. But you're going to see later, we will have an equation and we will be able to find the equation, like the equation will be given to you. Now, let's see if you picked up what's going on. I would like you to tell me, change this number here on the graph to 4. It says a velocity of 4 for 3 seconds. So we're going from 0 to 7, 7 to 10. I'd like you to tell me how the dude moved over these 10 seconds. And I would like you to tell me what is our position that the man ended at t equals 10. Where did he end up at t equals 10? Okay? Discuss with your neighbors what you see. You don't need your calculator at all because it's very like constant velocities, but if you want to, you'll get the same numbers. Talk to your neighbors about what happened. Ready, set, go. Go, discuss. Don't, try, go. You're right where I want you to be, Brown. That's good. Which is with an incorrect answer that's almost correct. All right, ready? Here we go. From 0 to 7, my area, my accumulation is negative 14. Let's see if you get it right. From 0 to 7, my derivative is negative, which means my position decreases. If I accumulate, which is done without a calculator because it's easy, I get negative 14. That's how much I decrease. That's how far I go to the left. Then from 7 to 10, I have a time interval of 3 seconds, velocity of 4. That's going to be 12. So my derivative is positive. My position increases. My accumulation of my derivative from 7 to 10 is 12. Where do I end up at t equals 10? If you said negative 2, you're right, but you're wrong. Now, negative 2 is a good number. I'm sorry for crossing that off and making you feel bad. You are correct that if you accumulated all of your velocities, you'd get negative 2. But what does this mean? You went down 14, you went up 12, you end 2 to the left of where you started. Well, where the heck did you start? So what's your answer? There you go. Your derivative accumulated only tells you how much you go down. It only tells you how much you go up. What is missing is something that's known, whether it's an equation or if we look back up in the problem, oh, I have an initial position. Oh, I start at 5. I add my total change. I accumulate my derivative to figure out how far I went in what direction from 0 to 7, and boom, I start at a position of 5. I subtract 14, I get a position of negative 9. Negative 9 is my position at 7. I start at my position of 7. I add how much I increase to that value, and I'll get a position where I end. And this is, my friends, the next step, the next layer of our sign analysis is understanding, based on accumulating your derivatives, how far we're increasing or decreasing. Negative 9 plus 12 is 3. What you guys did is you took your value 5, your x of 0, you added negative 2 to it, and then you're like, oh, I end at a position of 3. whether it's all at once or one step along the way. The accumulation of your derivative is just a change. How much we change. You still have to know where you start. So, the other layer to our sign analysis, if this is, say, 0, this is A, this is B. Sure, you can have accumulations from 0 to A, you get a number, but you have to be able to start with something. Whether you start with x of 0, whatever this number may be, add that number to get that next position. You have to add your amount traveled. You have to add your displacement. You have to add your accumulation to a starting value to figure out where you're going to be in the future. You got to then take that and add the next set of accumulations to figure out where you're going to be in the future. Or if you wanted to go all the way to the end, you could start, add up all of your displacements, and you are at your end. Okay? Now, I'm going to make it even easier for you. I am going to give you the graph of velocity, which you had on your quiz today. We did on our practice problems, but there are additional things inside the graph. Namely, this number, -2, that represents the accumulation of your velocity, the accumulation of your derivative from 0 to 1. This number 6 is the area or the accumulation of this derivative from 2 to 4. This -3 is the accumulation from 3 to 5. This accumulation is 5 to 6. Skip the review, go straight to the new. Where is the dude located at t equals 6? Not sure what to do, guys? What do we always like doing? A nice sign analysis. Start there. Add your extra layer and understand this new idea that accumulating your derivative tells you how much you go down or how much you go up. Where do I end up at time 6? Tell your neighbors. That's right. Make sure everybody else has got it. Where do I end up? You guys got it on this table? Anybody? You got it, Noble? No. Anybody at this table got it? Where do I end up? You're not locked in, Shadi. Sahoda's locked in. Yo, that -2 is the accumulation from 0 to 1 of x line.
Add all of them.
What do we get, Pemberton? What? 2 is a good number. It is my displacement, but it is not where I end up. 7 is the correct answer. Not 3. The correct answer is 7. Nice. Anders, you got it? No, you got that. Number 2 is important, but it's not the correct answer. Okay, ready? Here's the key. Here's the key. All of these values added up, guys, which I really feel like is going well, you guys adding them all up. All of the accumulations from 0 to 6 of my derivative are 2. Namely, we have a -2, a 6, a -3, and a 1 that we add up together to get 2. Cool? But all this is telling you is how much you go down or go up. We have to use a starting point and incorporate how much we go down and go up. We know, and you got to pay attention, and this always happens, is that it always kind of hides itself. You never really see it because you just started focusing on the graph of V. You actually know that your position at time 0 is 5. You start at 5. You then get to a position of 3. At time 1, position is 3. Hopefully that makes sense. I start at 5. I add my displacement. I now have a position of 3. That's here. Then I add 6. At time 3, I'm at a position of 9. Then, 2 seconds later, I've decreased by 3. At time 5, I'm at a position of 6. Then I increase by 1. At time 6, I'm at a position of 7. 5, my overall change in position is 2. Add them together, you get 7. That's where I end. The accumulations of my derivative just tell me how much I go up and go down. You got to know where you start from and go off of that. These are all the positions when I change direction. Let's see if you're really picking up what's going on. Go. The answer, what is the position at t equals 6, is 7. Yo, every single one of these values where I change signs is where I change direction. So x of 1 is 3, 9, 6, 7. Those are all the times. 3, 9, 6. Yes. You have to be like x of 3 equals this, x of 9, or x of 1 equals this, x of 3 equals this. No. -2? No.
I said -5. I don't know.
Close. Why?
You did it?
Yeah. The answer is -5. The answer is -5. Okay, so, guys, here's what's happening. We have our derivative. We have the signs of your derivative, and we have the displacements of your derivative. We have your position, increases, decreases, increases. We have the accumulations of your derivative are 6, which is telling me how much I go up. -2, how much I go down. And 4, how much I go up. I know a position at time 6. What do I do to get, say, my position at time 4? Well, I have to add 4 to get my position at time 6, which is 3. Where must I come from? I have to come from a position where like blank plus 4 equals 3. I must come from a position of -1. So you have your position, you're going to have to subtract your displacement. You're going to have to subtract your change. And now you have your position at time 4. So 3 minus 4, I got my position at time 4 is -1. And then I'm going to have to subtract my displacement from 2 to 4. So I got my position at time 4. I'm going to subtract -2. Okay, I got to go down 2 to get my position of -1. Well, if I go down 2 to get to -1, I must come from 1. 1 minus 2 is -1. -1 plus 4 is 3. This isn't bad. So now I have my position at time 2. I have to subtract my displacement from 0 to 2. I'm going to have to subtract 6, and I get that I start at -5. Or you want to do that all at once. You know your position at time 6. Subtract your displacement over the interval. You have your position was 3. Overall, adding up all your displacements, you go to the right 8. Go back in time. I must start at -5, my starting position. Are we good with this? If we're good with this, then this will not be so hard. However, let's learn some calculator techniques. Everybody, I want you to find the position at time 10. I want you to understand the movement of my object whose velocity is given. Let's all start by graphing the velocity. Everybody graph your velocity. When I do your homework video, I start with the graphs and then I go to the equations, so I kind of jump around. So if you want to do your homework in order that I do it to be able to check, go to the graphs first and then come back to the first page. Everybody graph 3 sine x to the 2/3. You need to do this. I'll show you all of the tricks of the trade so we can do kind of what we just did with the graphs, just now you're using your calculator. We have an interval 0 to 10, so we adjust our window to be 0 to 10. It's very important. If you press graph first, which everybody does, they press graph and they're like, ah, shoot, I forgot to change my window. Press on to pause. It's a very good little technique there. On pauses things so you don't have to wait for forever. Go to your window, 0 to 10, zoom fit. Okay, remember on is a pause. Here we go. Make sure you understand what you see. You see the derivative. You can look at the signs of said derivative. The derivative is positive and then negative. Changing signs at whatever this value is right here, which I'm just going to label as A. All right, there's some sign change A. My signs change at A. I'll just leave it as A for now, and we'll talk about finding it in a second. My signs then change to negative from A to 10. This is my derivative sign analysis. This is telling me how my position is increasing or decreasing. Okay, ready. Here are some tricks of the trade. We will be finding zeros of derivatives so often that it's much easier to have y equals 0 graph in your y2 and just keep it there. Yo, pay attention. Everybody, in your y2, just graph 0. You won't be able to see it, but it will be there. Press graph. It's there. Cool. Now, we want to find the 0. That'll be the intersection. Second Calc intersect enter, 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 you are going to find this A value. Everybody, pause once you have found this A value. If you want to write it down, write it down. Yes, Ahoda. Because you probably have it in degree mode, you AP physics crazy head. Make sure your mode is in radian. You need to be in radian mode. Okay. Somewhere you need to write down A is 5.568. Blah, 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 blah. You'd write the entire thing down. Okay. Now, watch and learn this very helpful technique. Since you found an intersection, you have a value stored for X. Go to your home screen, second quit, press X, press enter. The number you just found is stored as X. Let's change that to A. Ready? Everybody locate the store button. Store is above the on. Store that X as A, because I'm using A right here. Second, wait, not second. Store alpha A. Everybody figure out how to store. Now there's two things you can do, but trust me, the latter thing I'm about to do will be easier to use. That's what I do on your homework. You could either find your accumulations in your graph screen by doing second calc. Your calculators accumulate 7 from 0 to A. And a lot of students love doing this because it's nice to see that your calculator is doing just that. And that is telling me how much my position is increasing. But hold on. Hold on. Here's the better way. Because we're going to be doing this so much. Go into your home screen. Second Calc 7 is how you would do it on the graph screen. Okay, everybody, ready? Math 9 in the home screen. Math 9 in the home screen. Accumulate from 0 to A. Now, pause, 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 pause. Don't type in the equation. You already typed it into Y1. Everybody go alpha F4. This is the same as going vars, Y vars. Click Y1. Click DX. And you are going to get that number 10.95 in your home screen. Notice your calculator takes a while to accumulate. Now, what's great about the home screen is you could take your initial position at time 3. You could take your initial position at time 3 and you can add this displacement, this accumulation of your derivative. You can take this number, enter, and add 3. What also is helpful is you can grab this integral, this accumulation, and go to the left and just change your boundaries. And you will be able to do all the calculations that you need to. Remember, the amounts we increase and decrease only helps us if we have something we know, depending on the question. Yep. I'm about to keep going if you want to stick around.
Is it pretty much the same thing, just like going backwards like this before?
Exactly like what we did before, just going backwards. You're going to have to subtract versus add.
So
If it's like, if you subtract 8 to get to 10, You're going to add the 8 to get A, right? Taking your position at time A, adding your amounts that we decrease, amounts that we go left, we get our position at time 10. 5.499. The calculations we did is x of A is x of 0 plus 0 to A. We did x of 10 equals x of A plus A to 10, or x of 10 equals my starting position. Let your calculator do the entire accumulation of all of your velocities to figure out how we changed overall from 0 to 10. You will see us practice that when we do our homework. Go back, grab this, change it to 0 to 10. Add it to 3, we're going to get that 5.499. So this should be like 2.499. Yep, there you go. Add that to 3, you get that 5.499. Okay, remember, all the accumulation of your derivative is how much we're increasing or decreasing. I'm finishing a video. But do you guys have any questions? You good?
I don't understand what you know.
No, it looks like you're good.
Oh, okay.
I think they're all good.
Okay.
Doesn't matter. But sometimes on the quiz, you won't have a horizontal translation. You just have to find B, which means you might have to have an A that's negative.
Okay.
All right. Good to see you guys. And that brings us to this, like, without doing a full-fledged sign analysis, can you find your position at time 10? Yes, sure, because accumulating, or at time 9, sure, because accumulating my velocity, accumulating my derivative, will take into account all of the positive areas and all the negative areas. If I want to, like, I can say, hey, go calculator and accumulate from 0 to 10, and it will add the positive areas up here, which it's doing right now, and it's about to go to the next part there. It's going to add all that together. And you can kind of see what wins. Like, there's going to be more positive area here than there is negative area here, which means I go to the right more than I go to the left. All in, I end up 2.5 to the right of where I started. So full-fledged sign analysis helps, but not necessarily always needed. Understanding how much we increase and decrease and where we change signs. Going to be super helpful in the future when we're talking about maxes and mins. So great. And then going backwards, just making sure you understand, just like we did with the graph, if you have a future position and you want to know what's going on in the past, what do you have to do? You're going to have to subtract your displacement. Or solve an equation that kind of we could set up. For example, I could have x of 4 equals x of 0 plus my displacement, my accumulation of my derivative from 0 to 4. This is negative 3. this will be a number, I will subtract said number. Or what we kind of did earlier is, you know where you start, you're going to have to do the opposite going backwards. You're going to have to subtract this accumulation. If you get a positive value from 0 to 4, that means you increased from 0 to 4. You get to a higher value. Where did you have to come from? A lower value. Subtract that positive displacement. And in the future, we're going to talk about, and I talk about in the video, what would happen if these numbers flip-flop.